Hello, everyone. This is for the Talk to Code session regarding the code LLMs. If you're here for that, yes, please be here, or else there's another session which is happening around the same time somewhere. I am Kanch. I am a technical solutions manager with Google. And my partner in crime today is Chris, and he'll introduce himself during the next session. Yes, thank you. Thank you. So what I do in my day job is making sure with the generative AI boom, right, this past year, there has been an influx of conversations which we are having with customers with respect to how do I adopt generative AI in my platform. So I talk to customers across the globe, understand the patterns which we are seeing, the problems we are identifying, and build solutions that are most relevant to customers. And the way I got engaged with it is developer productivity is a space that has been good interest. Can you hear me okay? No? Okay. So that's a space which we have been working on for the past couple of months, and I'm engaged with Chris on developing this space further and further. Prior to this, I joined Google 6 years ago, and I was a AI specialist. I was working with customers on their AI problems. That's where I was. And now I'm in the generative AI space for the past 1 year. So, Chris, would you like to introduce yourself?
Yeah, so hi, I'm Christopher Grant, and I'll get into a little bit more about what I do in a little bit, but I'm a solutions architect. My kind of core function is to work with customers and with product teams and kind of fill that bridge between the gap there and kind of help customers understand the products a little bit more, but also help the product team kind of fill the gaps and things that customers are actually seeing in real life. And so a lot of my focus has been in the dev and delivery space and the app dev modernization. So where I come from on this is really more the pragmatic side about how do I actually use what we have and for a customer and actually implement that. So.
Thank you. So today we are going to take a little bit of history of how the code LLMs have evolved. There is a reason why we are going to do today. And I'm sure, if you are developers in this space, you probably have started with IDEs, and that's what you're exploring. That's where you need the assistance from. But that's not just developer productivity. Developer productivity is beyond that. And for you to understand that, we need to do a little bit of a history lesson. So it is going to be a bit of history of how code LLMs have evolved over the years, and also understand the research space in this area, where it's going towards, so that you can understand where we will be going. And then Chris would walk you through the practice of how you could do that today in Google Cloud. What are the things which you can leverage today? We'll talk about some of the challenges, limitations, because we all know it's not a perfect thing yet. So we need to evolve the space. And the last, I'll talk about some of the opportunities or things where we are seeing evolve towards, because we want to not just prepare you for today, but also prepare for what's coming tomorrow. So that's the goal of what we want to achieve today in the 45 minutes. And I think we'll cover the 45 minutes. So if you have any questions, we'll be hanging around outside to answer anything. Okay, how many of you have used your IDEs to generate code today? Good. How many of you have used Bard or ChatGPT to generate code? Okay, I see some of the same folks raising, so that's a concern. How many of you have used APIs to generate code? Okay, yes, thank you. These are helpful. So the prompt or the thing which I have written here is not perfect. And there is a science behind writing prompts, and there is a separate discipline which is happening of how to write better prompts, what are the ways to accomplish that. But where we want to be tomorrow is the ability of a world where any kind of natural language, you would be able to generate the perfect response for that prompt. For example, in this case, I started saying, create code in Python for printing a text. That's what my first statement was. But at that time, it didn't include any of the import statements. It didn't have declaration of variables, things like that. So I needed to come to a concise prompt so it could generate the code which I needed. And I'm sure all of the prompts which you all have tried, you probably did some of this, I'll try this variation, I'll try that variation, and you probably did use that for your prompting, right? But this is where we need the history lesson. Let's go to the next slide. And before I start, how many of you would call yourselves ML practitioners, data scientists, data engineers, ML engineers? Okay. How many of you are developers? Okay. So the major chunk here is going to be developers. So this lesson is probably important. So artificial intelligence in a space as such, it's not new. It's in 1950, Alan Turing asked, hey, can machines think and work? Is where it started. And artificial intelligence by itself is not just one topic. It's about, not just machine learning, it's about robotics, it's about natural language processing, all of that together. And then came machine learning, which was more in the 1980s space, where you are making the systems think and talk, and there was this, decision trees, nearest neighbors, things like that, which evolved. And then in 2012 is when the deep learning piece of it came. So let me walk you through this journey, right? How many of you remember the initial Google search? Where we had to, so for me, if I were to ask, hey, where is my nearest hairstylist, right? In the initial days of the world, you need to give hairstylist and the zip code. So it actually knows that, you are asking about the zip code. But then it came to a point that hairstylist near me. That's what you probably would do. And in today's world, I just have to go and give in Google search hairstylist. It exactly knows that it needs to find the nearest thing. So this is the learning or the search or the research which has evolved towards it. Think about prompting in the same situation. So in the prompting I did in the previous slide, what did I do? I had to be very explicit for me to get the code I wanted. But the way Google search has evolved, it needs to evolve, or it will be evolving to a place where I don't need to specify what I really needed or what is usable for me. So next slide, please. So to understand this better, in a traditional programming world, for me to, so here I'm going to explain more about what generative AI is, just so that we understand the context. In a traditional programming world, say if I want to explain or understand what is a cat, I'm sure you can't see this clearly. It's about, you specify what's the type of the animal, how many legs it has, what are the things it does, all of that. So that's how you declare a cat variable or object, and then you declare all of those. This is how we did before. And then in neural networks, 2012, around that time, we identified the cats as objects. We said, hey, this is a cat, this is a dog. So the next time the cat comes as a picture, it knows that, okay, this with labels, it identifies that this probably is a cat. What changed with generative AI? With generative AI, next slide. With generative AI, with the transformers, the PaLM and other APIs out there, we fed large corpuses of data. Data, not just books, it is any kind of data. It could be images, it could be videos, it could be code, it could be audio, it could be anything. We fed large corpuses of data and we let the system infer what the code or what it does. Here the point to note is generative AI would figure out that it's a cat because it has read so much of content and it knows it's a cat. For code, just imagine this. it should have seen a similar code for you to be able to generate the code. That's very important, because the reason why I keep having this history is to make sure we understand that the future would be different the way the research is going. So now we understand the generative AI pieces of it, we understand the machine learning pieces of it, and now we go to the history of code LLM. And code automation, auto-completion, syntax error, all of that is not new. We have seen this over the years. We have used IDEs over the years. These are the things which already existed. There's no machine learning to it, or maybe there is some which was used. But these were stuff which existed before. There's nothing new. But what came now? Next slide, please. So in the pre-deep learning world and all of that, there was rule-based. We were trying to understand how compilers, how regex work, how all of this works. That came into picture. And then we went into pre-LLM deep learning, which was where, neural search, trying to identify the best one. Again, this is very much to make sure the Google search works today, why it is working the way it is today. The last one is, how many of you have heard of AutoML? Okay, there are a couple of folks. So for folks who don't know what AutoML is, it's the ability to bring the data and have the system figure out what the machine learning code is. And that was a journey which is for machine learning folks. It's a democratization of AI. That's what we used to call it. Now the word has a completely different meaning, but that's what we used to call it. So the next one, the next slide, so these are basics, and then generative LLMs hit the scene. We all know how that changed, right? The moment, ChatGPT or anything which came, they said it's the end of coders. This is what, I can create a website just with a picture. Everything is going to work, and we are all still here. So there is something which is there, I guess. But as you know, the one which I have in there, the model is T5, which is I think it's 2020 or 2019. So when that hit the scene, it's more of understanding what the code is and how it's presented. But one thing here, we are still very much reliant on the model to have seen a code similar to that, because we all need to understand that generative AI is just a fancy autocomplete. It is not thinking. It's very probabilistic in nature. It's not deterministic. It doesn't do the architectural interference of what you and I would do as a developer. It's just a fancy autocomplete. So we need to really understand this, because when we talk about, hey, we can generate the code directly, yes, but there is a point of hallucination which we need to remember. And there are things which we need to understand why this cannot completely, take the course where we want it to go, but there are some research happening in that space. Next slide, please. So this, I think this was last year. Google did this research to do competitive programming. And this was the first time we were able to generate code that has not been seen before. If you have seen the competitive programming space, this is a place where it did not exist before. The code did not exist before. We are creating competitive code. We are generating the code. So in this instance, we created the competitive programming code, and the research paper actually walks you through, how they were able to do it, achieve it, etc. So Google it if you don't find it. But this is the AI-assisted coding where it hasn't seen before. Next slide, please. And then came the understanding code as a mathematical equation. So we are deviating a little bit from having seen the code before to understanding what is the architectural pattern behind that code which we are writing. And that is evolving towards generating even a new code, new programming language, new things to solve a particular problem. So that's where we are changing to. And again, this is not just from Google. As you could see, there are multiple papers out there which talks about how this space would evolve of thinking code as a mathematical equation versus thinking code as a natural language text problem. Next slide, please. So I have I don't think it's clearly visible out there, but I have an architecture slide which actually talks about just expanding the code to how do you think about it. Like, feel free to send me a message if you want the slide, happy to send it. But expanding the code to not just architecture, but also thinking about what are the additional components to make it much more safer, what are the things which you need to consider. But Chris would walk you through in live how this would evolve. But I want to take a few minutes in the next slide where I talk about what is out there in Google Cloud. How many of you have tried Bard? Okay, good number of people. So the question which today we came about is like, when do I use Bard? When do I use Vertex AI? So there are consumers, there are hobbyists, there are folks who want to just experiment as what you would do with ChatGPT. You use Bard. So I want to create an itinerary to Patagonia. I would do that in Bard. But for you to do in enterprise or an organization, you need enterprise controls. You need CMAK, you need VPC, you need all of that additional grade capabilities Chris would walk you through. Those you need Vertex AI. And Vertex AI has multiple components. Next slide, please. Vertex AI has multiple components, which you see in here. The left one is the foundation model families. The reason that is specified here is there are multi-modals for a foundation model. As we talked about, it's images is ImageN, and Cody is what Chris is going to walk you through today. PALM2 is our general large foundational model, and there are other foundation models out there. And then we talk about Bard, we talked about it. And then there is enterprise experience with bringing it together, Do It AI, Chris will talk about it further. And then this AI experience, because we know that for security, there needs to be a separate model. For medical field, it needs to be a separate model. So these are individual models which are created. But the point here is to make sure you understand that Bard is for consumers, or if you want to do your thing, if you want to have your kids do a little bit of experimentation, we would use Bard. Vertex AI is for your organizations to be able to adopt the platform better. So now I talked a little bit about the history, where we are today, because the context is important. Now, Chris will walk you through how you could leverage it today, and I'll come back to talk about a little bit of future of what we are seeing. Thank you.
That's right. Can you guys hear me okay, or do I need the microphone? All right. All right. Okay, you're gonna stress me here because I got to do two hands here. So this will be interesting. So I'm gonna try to show a couple things here. And we're going to do some live demos, which are always fun. So, be with me on some of this, all right? So really what I want to talk about is, what can you do with the models that we have today? And I'll read through some of this stuff. Can you see my cursor? Oh, you can. Cool. So there's really not a lot on here, but, some of the things you can do with code LLMs today, you can do code generation, code refactoring, you do code completion, explanation, document generation, testing. So there's a lot of things you can do, core capabilities of that. And then this is really, what does that do for your businesses? And so there's a lot of companies today that are trying to use code-based LLMs to, enhance organizational performance or provide new features. So what I wanted to show here was really that when we talk about some of the things at Google, and this is all preface to some of the stuff you're going to see later, so we're all about the foundation here. Speaking of which, the foundation model. So Conch was just talking about some of these foundation models here, the task-specific models. So these are all the base for Do It AI, which is our IDE code completion tool, and I'll show you a brief view of that. And that, that's in IntelliJ, that's in our Colab, that's in VS Code. And so that's a prepackaged solution that you could just go and start using, kind of more as a consumer, as a user. But then really what I want to talk a little bit more about today, and we'll get into this in a second, is the builder side. So if you actually want to build tools with this code LLM, how would you actually do that? And then more specifically, the work that I've been doing has been on the software delivery space. As I mentioned before, my background is mostly in software development. How do I speed things up for developers? So I'm trying to apply a lot of these to kind of that SDLC process. And so I'm going to show you a little bit there about how that might work. So the basics here are, we've got our Duet here. This is Duet AI. This is inside of the IDE. What Conch was mentioning earlier is that Duet AI actually extends throughout a lot of different consumer products, Google Workspace, Docs, email, the rest of that stuff as well. So Duet AI is really more than just the IDE side. It just happens to be, in this case, we're talking about where it shows up in the IDE. It also does code explanation, which is pretty cool in itself. But what we want to get into, though, is the actual back end of this. How is this actually working? So there's three major models at play here. So CodeGecko, we're going to actually do a little bit of a demo of this in a second. So CodeGecko is actually your code completion. So they're all built off of what we call the Cody model, which is really just an extension of that POM, but it's tuned for code. But then they're even tuned a little bit slighter for what their purpose is. So for this code completion one, the output isn't brand new generation, it's a completion of what you just typed. Code generation takes natural language in and gives you code out. And then code chat is, code in or natural language in, and it'll give you a mix of both out. So depending on what your use case is, you're going to want to kind of target each of those. So I've got some, I'm going to just whip through these real quick, and then I'll bring up this slide, the actual demo. So we're going to jump in and actually show you a little bit of the console. I just wanted, really what I was trying to show you here is kind of what I just said. The input here is a code snippet, and then the output is the completion of that. What they call the code bison is input of natural language text. So we'll go through, you'll see this live in a second. And then generated code output, and then texture code in and texture code out. So let's see if I can do this. How many of you have been into the Google Cloud Console before? Okay. All the rest of you, homework. All right. So this is our main page. One of the easiest ways to get to it is you go to Vertex. You type in Vertex. This is one-handed. You guys are testing me here. You do Vertex. You can do Vertex AI. I'm just going to click on this guy here, and it should pop me right into, in this case, the dashboard. Alternatively, you can go to the left nav here and search for it, but I don't like searching for things. So one of the things that's nice in here is we have this thing called the Model Garden. And inside the Model Garden is a list of all the different models that you can get access to. You guys able to see enough on there? Yeah. All right. So we'll go through just a couple things here, but what's nice about this is that we have some of our base models that we've been talking about already, but we also have a whole bunch of open source and fine-tunable ones, some of the ones that you're probably working with now. A couple of the other things in here, and I'm just kind of go over this high level so you can get a little bit of flavor for where we're going, is that you can fine-tune some of this. You can actually do serving through this platform. It's just like all the other Google products. The whole point here is we don't necessarily want to, tell you exactly what you want, what you have to do. You can bring your own models, and really we're here to help, provide the infrastructure and serve things for you and kind of reduce some of that overhead. Let's see, where am I going with this? So I have all these other windows open, and I have one hand. I feel like the Doctor. I've been back into Doctor Who recently. The 60 episodes. Nobody here? Doctor Who? Nobody? All right, come on. New specials on Disney. There you go. I need my sonic screwdriver. At any rate, so what I wanted to show you here was we're going to jump over here into I already showed you the Model Garden. Showed you that. So we're going to jump here into the example of how do you actually do this. I got my notes here, cheat sheet. So what I want to do is we're going to do code completion. So I'm going to not type in, I'm going to paste in, because that's how I am, a code completion. And we're going to use this CodeGecko that I just showed you earlier. So this one is just going to reply with the completion of this sentence. Hold on, let me zoom in for you. if I can do that. So I hit submit, and then down here, it gives me the completion of it. So you'll notice that by itself, this isn't valid code, but if you combine this with what was up above, it makes more sense, right? So completion is not the same as generation. So the next one I want to show you is a standard generation. So I'm going to snag that here. So in this case, I want to generate Vue.js code to calculate a mortgage payment. So I'll type that in here, and hopefully, yep. So this is code Bison, so that's the generate one. And down at the bottom here, it should give me actual code here in a second. There we go. So it gives me the actual Vue.js code, which is nice, and there's the JavaScript for it. And then the last one I wanted to show you is the chat interface for this. So chat doesn't necessarily mean the interface that you would go to as an end user. It can, but really what we're talking about here is the fact that there's the ability to have a persistent state with the model, so the model remembers what you did before. So what I want to do here is snag this code. It's just some sample code that I grabbed, and I'm going to ask it, explain the code that I'm giving you. So I'm mixing a combination of natural text and code. So we'll go ahead and run that, maybe. Oh, right here, sorry. So we'll run that. Now this one's at the top. So it tells me what I just sent, and then it actually gives me that explanation of that. So where this goes is that now I want to actually, I want to see if I can optimize this. So I'm going to say, oh, I have to put my hands down for this. So hold with me. So I'll say, can you optimize this code? And then it says here, this code is more efficient. So this is the back and forth. I didn't give it the code again. It had a memory of the code that I already sent it. And that's the thing you would expect with the chat interfaces. But the key point here is that we're actually doing this not necessarily through a chat interface. What you're seeing here, obviously, is a chat interface. But what I want to get to here is if you click on this view code, you can actually see the code that you need to input to actually use this technique in your own application. So we're going to go through and take a little deeper dive here. I just want to check my slides, make sure I'm on track. All right, so yeah, so the point here is what you'll tend to do is you'll tend to go in through the UI, through the Cloud Console, and do some rough work with what you actually want to get out. Maybe you'll use this view code button that's there, and then you'll switch over and pull some code samples out. But realistically, what you're going to do is be writing this in Python or some other language like that. So I've got a couple examples here. Let me just see what's, yep. So I've got a couple of things we're going to show. Actual code, and it's in an IDE, so it should be a little easier for you to see. So what I wanted to show you here is how easy this is to actually implement. So we're not really doing anything massive here, right? So I'm calling the model. Let me see if I pull this over a little bit here. I'm calling the model. I'm saying, hey, start the chat, and then I'm sending it whatever the user submitted, and that's it. It's literally like 3 lines of code. And so you can do a whole lot with just a few lines of code. Now, as Conch was talking about earlier, this really comes into play when you start to figure out, well, what is that query? So a lot of the stuff that you end up doing with this is not the software development side of this, it's all the other things that go with it. It's the fine tuning, it's the prompt engineering, it's how are you managing that context. And so we're going to talk about that here. I just want to kind of show you a little bit more of how this plays out. So we bundled this into a command line tool, and so this whole application is just a Python command line, nothing fancy. But what I want to show you here is now I'm going to ask it to generate some Flask content. So it's the same thing we did in the browser, but in this case, it's coming back through code, through the API, and that was just 3 lines of code. I didn't do anything crazy. I didn't, do a massive application, just 3 lines of code to do that. And now we can actually review some code. So in this directory, I have a whole bunch of code that you can't see here. So there's Java code here. So I wrote a prompt, and we'll take a look at that in a second. that's going to go through and review the Java code in there and give me some results on what I saw in there. Again, it's like 3 lines of code. Like I've been in the development space for a lot of years, but I mean, really, have I been developing? I mean, you've seen my code here, so. Hey, nobody laughing. All right, this is coming up here, I swear. So the other thing I want to show here as this returns is this instruction. So I will pull that up. Here's the review of the code that it pulled up. So how did we do that? It was really just, I already have it open here. It was really just the prompt. It's really just the prompt. What do we put in for the prompt on that? So we've got a whole bunch of different things in here. We're passing the code in. We have our instructions. You're a staff level programmer. Output the findings. If no significant findings, output no issues. You need to give an out if it doesn't find anything so that it doesn't have hallucinations. So this is just one example of a prompt. There's a whole bunch of other prompts that we have in here for different purposes, and I'll show you those in a second. But really the point here is that you can actually go through the entire SDLC process and start to add different things in there. So I wanted to kind of show you how we included this into a pipeline. Do I have this? Control click? No, I don't have this. Command click. Can I do it? Ooh, look at that, one-handed. All right, so I did a job earlier, and it passed. And the job results are basically, zoom in maybe. So basically the same thing, but in this GitLab job, I'm doing a code review for performance. It's giving me some results. Found a memory leak. I got a code review for, what is this one here? Oh, this is a general code review. And at the bottom here, I threw one in for security. And so it's talking about a JWT verifier. So the point here is that it's really pretty straightforward to start adding these things to your SDLC process. And then the last thing, little demo here I wanted to show you before I get back to slideware, was kind of the last. So if you kind of go through this, we're talking about how do you code in the browser, and then how do you actually do CI/CD processes with that, and then typically what you would actually do, I missed this one, is then include this in in this case, Chrome extension. So it's the same code, literally just those 3 lines of code, but I have it in a Chrome extension, and I can actually have a developer doing a code review of a merge request and actually selecting what they want to do, and then that same code review function that we just called actually is wherever they are in a browser. And so there it comes back there. And then the last one, before I get back to slides, because I know you guys like slides so much, is the documentation one. So in this case, this is more of a go through the Git report, the source files, and tell us what actually changed in the code from a human standpoint. So this is for a stakeholder, a business stakeholder internally with change management as an example. And then we can do another one here for, this one is here for an end user, and this is a little bit more happy response on that. So we'll let that come back here in a second. So it looks like code changes. So I just wanted to kind of show you that because the key thing here is that it doesn't take a lot of code to do this. It's all the techniques that are in play. We were talking earlier about some of the other use cases, generating, end user reports, but I think one of the big things is if you want to do batch jobs, like what if you wanted to convert, an entire code base from one language to another language? What if you wanted to, go update documentation on a code base that didn't exist yet? So some of these bigger things are kind of the things we're working on. How do I generate fixes for third-party tools? If I got a SonarQube report as an example, can I go through, find out where that is, and then actually generate the reports for that? These are all things you can do through the stack. But sounds great. Everything sounds great on paper. But what are the problems that we have? So the biggest problem that I think you guys have caught so far is how do you get the code base into the model to ask the questions, right? So the talk to code is kind of a basic standpoint. I want to chat with my code base. Typically that's done through fine tuning. I want to generate code for an internal API. You start to get into a little bit of a gray area there. I want to do automated code reviews like I just showed you there. What about generating new docs from old code? What about automated bug fixes? So what are the right patterns for each of these? So we're dealing with different levels, right? You got single file, multiple file, You got the entire app, multiple apps. There's a lot of things that we need to think about here. So am I going to be able to process smaller pieces? Probably a good best practice to begin with. That chat thing we were talking about, just a concern there is that it's a sliding window of context. So as things, you'll see this if you play around with any of the open source ones, you'll start to get lower and lower quality the longer and longer your conversation goes on because it starts to lose conversation ahead of time. What you heard earlier in the opening keynote is something we're finding as well, is that RAG model, the retrieval augmented generation, is actually one of the better patterns that we're seeing right now as compared to, say, model fine-tuning. So with model fine-tuning, you create a model that takes a long time to create, and then you're giving that to everybody, which sounds great, but then you actually have security concerns. What if you want to have different models for different teams? Now you have to support those. Also, how do you deal with the fact that I'm going to code something, you're going to code something at the same time, and we want to be able to see that in each other's code? The timing of that is not there, and the bandwidth is going to be challenging to get that updated. So just a couple last points here. So some of the other challenges, it's non-deterministic. So this is important, meaning that there is going to be some variability with the output. It's not necessarily just going to be yes or no. You can force that, you can push that with the prompt, but if you're dealing with something like a CI/CD pipeline that you want to have a binary yes, no, fail or not, you want to make sure that your prompt and your quality is really great. That multi-step generation I talked about earlier, if you want to do something on a full scale, you want to go step by step through that. Security, you don't necessarily want to expose other people's code where it's not supposed to be exposed. So thinking about that fine-tuning model versus RAG, maybe creating multiple models. So that's one of the things with the Google platform that's nice, is that you can actually compartmentalize the models into their different projects so people have different access. And then keeping things current. So if you're going to be having a fine-tuned model, you have that out there, and you do that this week. What happens tomorrow? What happens weeks after as people keep developing code? So those are all the problems that you're going to have. Now, Akansha is going to try to save me here.
So I think we are running short of time. So we are going to be focusing a little bit in the space of where we are evolving to. Did you refresh? Yes, yeah. So there are things which are our products which are coming in the market, which makes things a little bit easier. The context issues, and there is increased size context you see in the market today, and with the ability to bring a managed services platform, like using assistive tools like for Do-It-AI or the other tools that are out there. There are more enterprise controls which are coming, so that the security and on all the rest of the stuff which enterprises would care about. These are things which are happening today. But I want to talk about one research paper before we close, because this is, I think, where the future is evolving to. Next slide, please. Yes. So I don't know if any of you have heard of Smallville. No, it's Smallville. So it's a Google paper which was written. But yes, close. It's a TV show. So here, what they are trying to do is they are trying to arrange a party. And when you try to arrange a party, then there are multiple tasks involved, and each of the tasks called other tasks, and that needs to be handled. And sometimes the response is going to be a negation, so it comes through the loop. The similar logic is being applied to code. So the code which you and I create are all task oriented. It does something, and then that leads to something, and if that doesn't do well, then we need to create code, or we need to create a debug logic, or we need to create some of that. So in the next screen, we talk about how this is, okay, this slide is definitely not visible. But we talk a little bit about how you would be able to use some of the Smallville concept. Please, I would suggest do a search. It's more breaking up the task to smaller tasks and running the tasks individually. So that is one of the things I want to close with today. Of when you think about codes today, don't just stop with IDEs. Don't just stop with using ChatGPT or Bard. there is more to it in the conversation with developer productivity of how this is going to evolve. And as you know, as all of us are thinking this through, what is future going to look like is something we can just, you know, think, okay, this is where the research is heading to, this is how it will come, but we need to be better prepared for tomorrow. So, next slide, please. So, thank you for, you know, having us here. We would love your feedback. Please scan that link, and, you know, if you could drop in a comment, like it's just a couple of questions, it would give us, you know, things which we need to focus on, and it'll help us, you know, to do better. Is there, like, what is the time? Okay, we have 2 minutes. If there's one question we can answer. I saw him first. And then after the session, we'll hang out to answer questions.
So most code that you use the interface with the database one way or another. So how do you make the code generator understand the database? Do you have to put it in an object or a class or create a table statement or what?
That's a good question, because that is my space too. Apart from developer. Oh, okay, yeah. So I'll repeat the question. So his question is, most code needs database integration, which needs to be schema aware. So how do you use the existing code tools to create the schema aware code which is needed? Did I understand the schema? Understand the schema. So my other solution track is text to SQL, which is also a growing interest in this space. People want to be able to interact with the structured data using natural language. So that's my other, you know, track. There is a lot of research in this space, a lot of players in the market, but one key concept is understanding the schema to generate the code is important. And for understanding the schema, the things which is evolving to, there are 5 things which are needed for understanding the schema. One is the table name and the table context, because I had a customer who had the table name as EABEY to storing agent information. That's what it is. So it needs to be schema aware. It needs to understand the business context. And then in the table, there is columns, column data types, primary key, foreign key. These are the things which needs to be aware in a business context. So what we propose is having a layer, embedding layer, to understand first the schema of the database, and that could be fed to the code LLM to be able to generate the SQL statement. And that would be the thing which the coder can, you know, introduce to the code. There are things which are in the market which does some of that. But if you could Google SQL Palm paper, they go through in detail of how each and every step would be, you know, processed. Did I answer your question? Okay. So I hope you took the time to send us feedback. We would love to hear from you, and we will be hanging out outside to answer any questions you might have. Thank you for the time, and we hope the session was helpful for you. Thank you.
Thanks.
Keep it for a little bit.